Hey everyone, welcome to, I guess, part three or chapter two, whatever you want to call it. So we've done the first chapter talking about the basics between numbers, ints and floats, and strings. In chapter two, we're going to be talking about how to compare things, how to pull in, and how to flow an inner side of program, sometimes called control flow. One thing I do want to impress upon you, if you have not completed all the questions from the end of chapter one, please stop, go back and do all of them. It might seem super simple. That's great. If it is, fantastic. Knock out all five. I think there's five. For each one of the chapters, it's imperative that you do all the different exercises because it's going to stretch different parts of your brain. If it's too hard, that means you're going too fast. Go back, talk to me, ask questions. If it's too easy, fantastic. It'll be done quickly because eventually it won't be too easy. And if it's too hard, okay, let's slow down. Let's talk about it. It's imperative that you're able to solve each one of these questions before you move on. Otherwise, you're going to hit a wall and you won't be able to move on anymore. So please do each of the questions as they go along. So, that aside, stepping off the soapbox, let's start talking about stuff. So for chapter two, like I mentioned, control flow, we want to be able to compare things. We know what numbers are, we know what strings are, but what about comparing things? Because a lot of times we want to make decisions, hence the name of this chapter. We want to know if this person is safe to give insurance for. That was my first data science job. We want to know what kind of output we want on our website. You know, do we want blue? Do we want green? What do we want? In order to make decisions, we need to be able to compare things. And so for this for problem three, for the first problem of the chapter, we're going to be taking a look at two, I think they're basketball teams. And so the apples and bananas. And apples, both teams have scored free throws, 2 pointers, normal shots, or 3 pointers. And the question is who won? And so we're going to be able, or maybe there's a tie. And so we're going to input all six of those values, the 3 pointers, 2 pointers, free throws for apples, the 3 pointers, 2 pointers, and free throws for bananas. And those are all going to be string values because remember, if they're coming from the command line, that's going to be a string value. Then we're going to output a string value likewise. Remember, I'm trying to be more precise in my input and my output string. A for an apple win, B for a banana win, T for a tie. And so once again, we want to be able to take that in. And so the structure of the algorithm that I'm thinking of right now is we input it, we aggregate those results, sum up those values so we know how many how many the apple team scored and how much the banana team scored, and then we can compare them. And so we need to be able to compare things and we need to know how it flows and how we can make those decisions because it might not always be the Apple team who wins. So we need to be able to control that motion. So first, let's start with the basics. You'll notice my terminal has multiple command lines or multiple terminals today because they're going to do different things. I'll talk a little bit more about that in a little bit. Um, but in order to do this, we know from mathematics, if you remember back from school, that we have various different types of things of comparison. These greater than, less than symbols you've seen before. I'm not going to spend a whole lot of time on that. Um, and so those values allow us to be able to get what's known as a new type data type. We've had strings, we've had ints, we've had floats. Now we have what are known as Boolean, true and false. That's all the only values that are allowed. And so technically, Booleans uh, do have methods just like the others, but it's not really useful because you don't really need to use. I've never had to use them, but technically that is true. But if you remember from before, we can always check to see things. So we've got our ints, we've got our floats. Like I said, we have our Booleans. Now you'll notice in Python that true and false are all lowercase except for the first letter. This is not necessarily going to be true for other languages. I think JavaScript and Java both have all lowercase. It's going to be dependent on what language you're in. In Python, the first letter is capitalized and the rest are lowercase. Just a heads up. Another cool thing about type that your book brings up is you can do operations. And it's just going to look at what the output, final output might be. So we know that in this 12 plus 15 is a 27, which is also an int. Hello plus world would be hello world, which is also a string. Obviously, if we try to add other things together, it might do weird things. Like if we try to add a number to a string, that would cause an error. Okay, but if we, as I mentioned before, true and false are the type bool or boolean. And that's related to because we're going to be comparing things. 3 is indeed greater than 2, so we get a true value. So these will allow us to control the flow of how the algorithm works. This also works for strings, but they're going to have to be an exact match. So hello equals hello is indeed true. Hello is equal to hello, not true. Other cool things, though, we could do. Ah, silly me. He is the first two letters, and so you can literally see that inside our equation. So that's a cool little thing they mentioned there about Apple, but you can see and compare that too. So these are another type of comparison operation. We can check that. I use this a lot. Okay, cool, great, but not actually what we want. These comparisons will allow us to say, hey, if the apples have more points, apples wins, banana wins, have more points, then that works. But notice what I just said. If statements are your bread and butter when it comes to control flow. If. So here's an example. If our apple total is greater than our banana total, print A. So let's do that. Notice that at the moment it does not like that it doesn't know what that might possibly be. So let's fix that. So notice no worrisome yellow squigglies. We're probably going to be fine. So let's check that. So for the winning team algorithm, if I say Python winning team, it indeed works. If I change this to this though, nothing outputs. Why? Because the banana team was bigger and we didn't tell it what to do. So this could be another situation here. So in this case, the banana team won, but we don't have a current idea of what might happen here. So one thing we could do is we could separate this and do the opposite here. If banana total is greater than apple total, print B. So we can put two if statements right next to each other. Works just fine. But another way that we might want to do this is with an else if statement. This allows us to string things together in a way. So if the first thing isn't true, then check else if the next different thing. And this would equally work here. And this could happen, we could do a bunch of different things. So in the case that I mentioned, I worked in insurance. If your BMI is super low, then do underweight if your BMI is less than this value, then normal weight if less than this value, then overweight. And like you can notice us classifying it based on the doctor's values for BMI. That was one of the cases where we chained a number of these in a row. But notice we could also just straight up do else. Why are we yelling? Ah, so in an else command, you don't put any of this control flow comparison stuff because it doesn't need that. Doesn't need it at all. But here's the problem with just putting else there. They're tied. But because I didn't put a control flow, it's automatically going to give it. It's automatically going to give it to banana. I don't want that. So what I might do is at the end of a if elf list, I might chain them together at the end. Right? So in this case, oop, B is indeed winner because I changed that back. But if it's tied, like so, then I do get time. So at this point, we're going to do something similar to what we did last time. I am going to name them based on the team values. I'm going to keep this really simple. You can do it a number of different ways. I think your book does it one way. I'm going to do it this way because it makes sense in my brain. But do what you will. Yeah, they spell it all the way out. I feel like that's unnecessary. But do what you want. I think this makes sense. Nope. There we go. So notice input, the first three are apples, then the next three are bananas, and then comparison. But one thing that we do need to realize is that these are 3 pointers. So I might need to do 3 times. These are the number of these events. So I do have to make that adjustment. This is where it's useful to give it a useful name. Now I don't have to worry about and so in my case, putting the 3, 2, and 1 after it is helpful for me to remember to do this. But you can see the book has their own way of doing it that is helpful to them. Okay. And at this point, we could enter what we will, right? So let's say Apple did 1 3-pointer, 4 2-pointers, and 2 1-pointers. The banana did 2 3-pointers, 2 2-pointers, and 2 1-pointers. So Apple won because that would be 3 plus 8, that's 11, for a total of 13 points. And then for banana, that would be 2 times 3 is 6, plus 4, because 2 times 2, so 6 plus 4, that would be 13 to 12. Close game, but Apple barely won. So that is the basics behind how you might do a control flow. There is some interesting control concept checks about what is going on here. I suggest you take a look at them. I personally think the second one, the one on the end of page, you know what? Let's do that actually. Uh, do, do, do. There we go. The difference between snippet 1 and snippet 2. So in this particular case we have here, do the snippets of code do the exact same thing. So in this case, we have the temperature printing warm if the temperature is greater than 0, 0 if it's equal to 0, else it prints cold. Remember, we're chaining them together. Now in snippet 2, it prints it if it's greater than 0, same. If it's else if it's equal to 0, print 0. But notice there's no indentation here for the print. Python's important when it comes to indentation, and there's no else statement here. So this means if the temperature is equal to 5, it would print warm, and then it would also print cold. Whereas here, if it was temperature is equal to 5, it would just print warm. So please take a look at these concept checks. I think they're useful. Helps test to see whether you understand it as well as you think you do. But that's everything. I'm going to do the telemarkers in just a half second, but hope this is helpful. Have a great day.